All right, welcome to the calculator active section of the video. I am not, for the sake of time, going to do every problem. I'm gonna give you some hints, and then you have to put in your calculator to get the right answer. So I'm just not going to go through all of that because it's just going to be too much. So it says, what type of correlation exists between the grade level and time spent on homework? So with this problem here, some hints on this problem. You can put this in, erase my Mr. O'Neill. You can put this in hours form. So you can have 8 and then the 2 hours and 10 minutes. Oops, I'm not on my tool, am I? All right, 2 hours and 10 minutes will be 2 hours and there's 60 minutes. So 2 hours, 2 and 10/60ths, which gives you 2 and 1/6, which gives you 2.16 repeating, or 167, whatever. Y'all can do that, or you can turn these into nothing but minutes. So you can say 2 times 60 plus 10. All right, so you get 2 times 60 is 120 plus 10 is 130. So you can say, hey, 130 minutes. Put them all in 130 minutes. Put them in your calculator. Don't forget to turn your diagnostic on. To where you turn your diagnostic on, you hit second, then you go to the 0. I'm gonna put the 0 down here because above the 0 is catalog. After you do that, you will go to diagnostic on, because it's not on automatically, and when you reset, it won't be on, and it'll give you an R, and the R, I remember doing this earlier, is 0.95, and so clearly it is a strong positive correlation. That's what my R was. But your R may be a little less than that, but more than that, whatever. I converted mine like the 2.167. And that's what I did. Until somebody's like, can we turn them all into minutes? And I was like, yeah, y'all probably will more likely turn them all into minutes. All right, so it says the data below represents the ages of several people in class. What effect does Mr. Smith's age have on the data set? So he is 45. Clearly, that 45 don't want to be in that circle. Who cares? If he's 45, look at the rest of these numbers. What is that going to do? It's going to cause the age of the mean. It's going to cause the mean to increase. That's one thing we know. All right, so for number 19, the answer has to be C. Okay, moving on. Trying to move on. Really trying to move on. All right, for 20, select the answer given. So I went over 20 in class. I told y'all that, and then somebody in the other class was like, hey, it has to be quadratic because it's asked for minimum, and we don't have minimums in linear equations. We don't have minimums in exponential equations for number 20. So this table is a quadratic table. So when you put this into your calculator, I'm gonna do that now. Actually, I'm gonna pause the video so I don't waste time. Y'all hear me? All right, I put the numbers in my table. I'm going over to calc. Instead of hitting 4 for linear regression, I'm gonna hit 5 for quadratic regression. I'll press enter, and get my equation. They tell me that my A is 1. They tell me that my B is 8, and that my C is 16. So the equation will be y is equal to x squared plus 8x plus 16. So it says a smaller minimum, larger minimum, smaller y-intercept, larger y-intercept, larger than the y-intercept of function, g of x. So this y-intercept, f of x is 9, g of x is 16. So f of x has a smaller y-intercept, 9, 16, smaller y-intercept. All right, we need to find the minimum, larger minimum, whatever. But to find the minimum, everybody is negative b over 2a, and you have the order pair. All right, so if you did the minimum of this one, be negative b, negative 8 over 2a will be negative 4. Notice, y'all, if you look right here, this is where the y values begin to become symmetric. So that has to be my vertex, which is my minimum. But I'm just pointing out, something. Just trying to save lives, I guess. All right, so you'll get the same minimum. They'll be both the same. Try me. All right, 21. Find the value of x in the equation shown below. So we distribute, we get 3x plus 21 minus 5x. This is all calculator active. Is equal to 10x minus 3. All right, combine like terms. Negative 2x plus 21 is equal to 10x minus 3. Slide to the left. Slide to the right. This is probably lagging a little bit because I got a video uploading to YouTube in the background. So we get negative 12x equals to negative 24. Divide by negative 12. Divide by negative 12. X is equal to 2. 21 is 2. All right. Box or circle. Moving on. 3 systems of equations are shown below. Drag the choice. All right, so one solution means that we have a different slope, because if we have a different slope, if we have a different slope, the lines will eventually cross. All right, so no solution means that we have the same slope, but different y-intercepts, because if we have the same slope and the same y-intercept, we'll have u. Same slope, same b. Because infinite many solutions is the same line. Okay, so same line. Parallel. Intersecting. All right. So which one will have, well, let's look at this one. So if I went to solve this and I multiply this entire thing by 2, I have the same equation. It'll give me 6x plus 4y is equal to 12. If I take this equation right here and divide it by 2, I'll have the above equation. So this has to be infinitely many solutions, or many solutions, whatever. Right over here, if I went over here and I solve for y, subtract 3x and divide by 2, subtracting 3x will give me a negative 3x and divide by 2. That gives me a negative 3 half slopes. 3 half slopes. And then over here, I subtract 2x. So that gives me negative 2x, and then divide by 3. That gives me negative 2/3. So this is one solution. That means this one has to be, what? No solution, because the slopes are the same. If I subtract 2x from both sides, I get negative 2x, and then eventually divide by 5. I get negative 2/5x. Subtract 2x, and then eventually divide by 5. I get negative 2/5x. I have 2 different y-intercepts. That'll be 8 over 5. This will be 3 over 5. So this will be no solution. Y'all remember the symbol? Yeah, buddy. I think that's the symbol. That looks more like theta. Okay. All right. Number 23, which equation is the line that passes through this and perpendicular to this? Before we can find out what's perpendicular, we need to find the slope. So we have 3x plus 2y. Y'all see that moving? Is equal to 6. So we subtract 3x. A lot of this is going to move because this is going to work its way down. And we get 2y is equal to negative 3x. We don't need you to move though. Negative 3x plus 6. I was about to write 2. Divide everything by 2, divide u by 2, divide u by 2, and we get y is equal to a negative 3 halves x plus 3. The y-intercept is not important. What's important is the slope, and we're looking perpendicular. So we flip u and change the sign. So we have the perpendicular slope will be 2/3. So is there 2/3? There are 2 2/3. So you're out, you're out. And we want to go through 6, negative 2. So we have 6, negative 2 is a point. So y equals mx plus b. And so we have negative 2 is equal to 2/3 times 6 plus b. 2/3 of 6, 3 goes into 6. 2 times 2 is 4. So you have negative 2 is equal to 4 plus b. Subtract 4. B is equal to negative 6. You have to be right, buddy. And we keep it moving. Moving. What is the explicit formula of the geometric sequence? This is where y'all be getting on my nerves. We've been doing arithmetic sequences, but this is geometric sequences. So this is my first term, everybody. First term, a sub 1, right? And then the common ratio, because, you know, difference is arithmetic. Common ratio Come on. Common ratio means that I'm multiplying by something. What am I multiplying each time? Oh, it looks like I'm multiplying by 2. So we know A is equal to, this is our normal exponential function. So we know that now we have A is 3, first term, times 2, but we know what geometric sequence is. We have the R minus 1. Whether y'all remember it or not, you can at least get the 3 and the 2 in the right place. Like, come on. Whether you remember the n minus 1, this is the only one that has the 3 and the 2 in the right place. And it's n minus 1. Because that gives you the previous term. This is my first term. So if I put 1 right here, 1, I'm just doing this for the sake of math. Okay, 1 minus 1, which is my first term, is 0. Anything raised to the 0 power is 1. So this would be 3 times 1, which gives me 3, which is this first term. That's why it's n minus 1. Okay? All right, so whether y'all remember that or not, it's there. Get my space back. Give me my space back. Give me my space back. All right, okay. I'm lagging. Gotta move up. Terry is given 2 salaries. Oh, hold up, buddy. Hold up. Move too fast. Moving too fast. Moving too fast. Slow down. You're moving too fast. Terry is given 2 salaries. 2 salary options. The first one is starting salary of $20,000. That increases $500 each year. That's linear. So I'm gonna write it as this in slope-intercept form: 500x plus 20,000. The second salary is 20,000. That increases by 2.2% each year. He is in the company. Well, that's exponential, and that's exponential growth, buddy. All right, so this is my initial value. So y is equal to A, which is 20,000 times 1 plus, this is as a decimal, is 0.022. So I can rewrite this as y is equal to 20,000 times 1. Raised to the x power, 1.022 to the x power. It says, how many years will Terry have to be with the company for the salary with the second option to be greater than the salary with the first option? So we just put this into our table. I'm putting it in the y equals. I'm writing in 500x. Y'all can hear me typing. Plus 20,000. The next one I'm writing in, I'll type it in, punch it in, however you want to look at it. 1.022 raised to the x power. I'm hitting second, and then I'm hitting graph, which is the blue table button. And I'm going, I'm about to clear something. And I'm looking, it says, how many years would have for the company, blah, 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 to be over company, blah, blah, blah. All right, so 25, when you look at this, all right, so when you look at your table, you'll see that at 13, the linear equation is 26,500, and the exponential equation is 26,539, and that's the first time it's over it, because at 12 is 26,000, and the exponential equation is 25,968. So 13 is our answer. Woo woo! Give me my space back. Give me my space back. All right, moving on. Karen and Mary saving money. Karen has $1,035 and deposit an additional $125 a week. Mary has $22,000. Think about the last problem. $2,250 or $2,250 and deposits an additional $100 each week. What is the minimum number of weeks it will take Karen and Mary to have a total more than $5,000 in savings? All right, so they're totaling their amount. So let's write Karen's expression. So Karen, she has already $1,035, and then she's adding $125 per week. We'll say that to be W. Miss Mary, Sister Mary, has $2,250, and she's adding $100 each week. That's like 106, but it's really 100. Whatever, y'all get the point. All right, and then we want that to, it says, have a total more than 5,000. So we need to add these up, and then we want to put it more than 5,000. So it's going to be greater than 5,000. And we add this up. All right, so if I keep this out of, let me get out of here, 1035 plus 2250. I probably did this in my head and faster. 3285 plus, this is going to give me 225W. Subtract 3285 from both sides. Sorry about the handwriting, people. And we end up getting 225W needs to be greater than, minus, subtract that from 5,000, 1715, divide by 225, divide by 225, and we get W has to be greater than 7.62. So it says, what's the minimum number of weeks it will take Karen and Mary to have a total more than? So at 7 weeks, they're not more than, but at 8 weeks, they are. So the answer to 26 is B. All right, give me my space back. Give me all my space back. I should probably pause this. This is a lot of erasing. I mean, y'all can click next. Y'all don't have to watch me erase unless you really love this, which is kind of weird, but whatever. There's some weird kids I teach. My space. Oh, don't play me but for my space. All right. Rhea doesn't like the commentary I give. Who cares what Rhea likes? I care. Francis bought 2 dresses and 1 pair of shoes for $7.50. So 2 dresses plus 1 pair. I hate using S's, so I'm gonna say 1 pair of shoes for $70.50. The shoes cost $15 more than the dress. So shoes cost $15 more than the dress. And they want us to, what do they want us to do? How much did a pair of shoes cost? So we have this in this form already. Now, some of you all, if you want to subtract D from both sides and use elimination, you can, but it's already set up for us to use substitution. So we have 2D plus D plus 15 is equal to 70.50. So we get, let me do that, 3D plus 15 is equal to 70.50. Subtract 15, subtract 15. All right, and we get 3D is equal to 70.50 minus 15, 55.50, and then divide by 3. We get the dress costs $18.50. All right, and so the dress costs $18.50. Then the pair of shoes is $18.50 plus 15. So $18.50 plus 15 gives me $33.50. So the answer is C. I don't feel like erasing this one. Let me see if it messes up the problem down here. Yeah, it does. Look at that 35, 36 sitting down there. So I have to erase it. Okay, whatever. Sometimes you gotta do what you gotta do, right? Right. Go away, go away, go away. This erasing probably adds on like an extra 5 minutes doing this silliness. All right, 28. It says, which scenario is best modeled by a linear function? Well, if the rocket X seconds after it is launched, we know rocket launching, that's going to be quadratic. Radioactive element decreases half every X, that's exponential. This right here, total has changed 2% every year, that's exponential. Total price of X shirts that are on sale for half off, yes, clearly. That's linear. All right, 28 is D. All right, let's move on. Next problem. In the table below, Sally recorded the height of a plant after different amounts of time between which 2 days did the plant grow the greatest rate of change. All right, so in growth per day, I know I should have looked at, but no, you want to leave stuff here. All right, so 2 to 5 gives you 3. 5 to 10 gives you 5. You're growing by 5. 10 to 18 is growing by 8. And then 18 to 36 is growing by 18. Well, 3 to 7 grows by 4. 7 to 15 grows by 8. 15 to 20 grows by 5. And then 20 to 35 grows by 15. All right, so the rate of change would be 3/4. The other one will be 5/8 because it's changing y over changing x. The other one will be 8/5. And the last one would be 18/15. All right, 3/4 and 5/8 are less than the whole, so we know those are out. But 8/5, 8 divided by 5 gives me 1.6. And then 18 divided by 15 gives me 1.2. So 8/5 is the largest fraction. So that's between 15 and 20, which is B. The length of a rectangle 3 more than 3 times its width. The perimeter of the rectangle is 174. What is the length of the rectangle? So we have a rectangle as such, and it's 3 more than 3 times the width. And then the perimeter of the rectangle, well, we know that the width has to be W. The perimeter is 174. That's going around. So if I'm going around, that means that this side is 3W plus 3, and that means that's W as well. So if I add all my W's up, I get 6W plus 2 more W gives me 8W. And then add 3 and 3 gives me 6, and that's going to be equal to the perimeter, which is 174. So we subtract 6 from both sides. Get 174 minus 6. I can't believe I'm using the calculator for this because it's here. It just spoils you. It goes 168, and then divide that by 8, divide that by 8. We get 168 divided by 8 gives me 21. So W is equal to 21. It says, what is the length of the rectangle? That's the width. So we have 3. See, it's there, but it's not the right answer. 3 times 21 plus 3, which is going to give me 63 plus 3, which gives me 66. All right, time to erase. I wonder if it's an all clear button. Let me look real quick. Because it really would help out. Add pen. There's an eraser, but eraser is not going to do anything for me. I need to just clear everything. Ink to shape. No. So there's not even an all clear button. So y'all gonna watch me erase. All right. Numeric response. The function. How long is this video? I'm gonna stop at 25 and move on to the next one. The function S of n is equal to 2n minus 5. What is the rule of the nth term in the sequence? What is the sum? Is the rule. Okay. What is the sum of the first and the sixth term? So if I do 2 times 1 minus 5, that gives me a -3. And then 2 times 6 minus 5, that's 12. That gives me 7. The sum, 7 plus a -3. Or should we write it 7 minus 3 is 4. All right. The table below shows the amount of gas in Aaron's car after he's driving, blah, 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 which describes the slope of the line of best fit. So we have to put this in our table. And I just remember the answer because I did this earlier before I created the video. When you put this in your table, you get the slope to be 0.035714285.7. And so you have to figure out which one represents. For every mile driven, the car uses about 14 gallons of gas. 14 gallons of gas for every mile driven. First of all, it's that's your x. So that says that because it's changing y over changing x. That's what you have to pay attention to. So they're saying 14 gallons. That'd be 14 over 1. Clearly, that's not what we're looking for. For every mile driven, the car uses 28 gallons of gas. So that'll be gallons is y. That'll be 28 over 1. That's clearly not what we're looking for. For every 14 miles driven, the car uses 1 gallon of gas. So that's going to be 1 over 14. All right, because 1 gallon, 1 over 14. So 1 over 14 is 0.0714285.714. That's not what we're looking for, and this is going to be 1 over 28, which is what this is, D. So when you use the line of best fit, your A is that. That's what your A is equal to, which is what that is equal to as well. All right, moving on. It's been 25 minutes. All right, so I'm going to stop this and make one more video. So this is through 32.